When we're talking about our intercepts, what we're talking about are locations where one of our variables ends up being 0. That is, where we have a lack of something in our equation. The x-intercept, or intercepts, you may have more than one, are the locations where your equation, your graph, whatever, crosses the horizontal axis. So if you're going to cross the horizontal axis, you're crossing this line. That means you're not doing anything vertically, and as a result, at our x-intercepts, we have that the y value is equal to 0. So we're describing points of some form x, 0. Meanwhile, for the y-intercepts, we're looking at points where it crosses that vertical part. If you're crossing the vertical part, that means you're not doing anything from side to side. So at those points, that would mean that x is equal to 0, and we'll have points of form 0, y. So thinking of this picture, hopefully you can get some sense for what these things look like. Where if we think back to our last example, not the example with the absolute values, but with talking about the money you could make, the intercepts, both x and y, happen to actually be at the same point at the origin, because the point where you didn't have any money, where y was equal to 0, is the same as the point where you hadn't worked any hours. That is, when x was equal to 0. So sometimes when we're talking about intercepts, the x and y intercept, or intercepts, can occur at the same time, specifically when the origin is crossed. And for that matter, these things don't need to necessarily be unique points either, as you can have a whole bunch of them with one equation, although you don't get quite as much of that with the basic stuff we're seeing just now. That'll come later. Anyway, for now, let's take a look at a quick example with this. So for this example, we want to identify the intercepts of the graph given here. Now, for this, basically all I have to do is look at that picture and identify the locations where the axes get crossed. So, if we want to find the x-intercept, remember that means we're looking for things where we hit the x-axis. And if we're hitting the x-axis, that means y is equal to 0. So, for our x-intercept, so I'm going to abbreviate x-int, that would have to occur, like I said, at points where y is equal to 0 and x is equal to something, and the scale is a little bit small there, so you might not be able to see it quite nicely, but the x value there would be -3. That is our x-intercept, because that is where the graph hits the x-axis. On the other hand, for our y-intercept, we are looking for a location, so I'm going to abbreviate y-int, that's generally how I'm going to abbreviate these. We're looking for a location where we hit that vertical axis, so we're looking for locations where x is 0, and in this case, again, the scale's a bit small, so it's easy to miss. We're looking for the point 0, 5. If you have a graph, that's the idea for being able to find your intercepts. If you have an equation, what you would do is set either x or y equal to 0 and work from there. And for something like this, something nice and linear, it's not so bad, but as we'll work further, we're going to see that finding things like the y-intercepts is not such a trivial process, but it is a very important one to learn how to do. Before we get to that, though, we're going to take one more look here, talking about applications and how we can make interpretations for situations where our equation, it's a lot of alliteration, describes a particular location, not really, but situation.